Let's try to solve this problem by using the LU decomposition. So first of all, we can arrange the equation into matrix format, where your A is the system matrix from the blue coefficient here, and on the right hand side, this is the matrix B. In the first step, we need to decompose A to the L and U matrix by using the Gaussian elimination. For example, to make this 0, we have the factor F21, which is 0.1 divided by 3. So to make this 0, we have the factor F31, which is 0.3 divided by 3. Take the second row here, minus with the first row here, and then your first row must be multiplied with factor F21 here. So for example, 0.1 minus with 3 multiplied with F21, you obtain 0. 7 minus with minus 0.1 multiply this factor, you obtain this answer. Lastly, negative 0.3 minus with negative 0.2 multiply with 0.1 divided by 3, this factor, then you should be able to obtain this answer. By using the same approach, to make 0.3 here become 0, we have to take row 3 minus with row 1 multiply with the corresponding factor, which is F31. So 0.3 minus with 3 multiply with F31 here, you obtain 0. If you take the negative 0.2 at row 3 minus with the negative 0.1 at row 1 multiply with the factor F31, you should obtain negative 0.19 here. And then you continue, take the 10 minus with negative 0.2 multiply with this factor, then you should be able to obtain 10.02. So you success to obtain the first forward elimination result, where you can see the prime here indicate the first forward elimination result. So to obtain this component and make it become 0, we need the factor F32, which is negative 0.19 divided by 7.00333, this component. And then you can substitute into this equation. Take the row 3 minus with the row 2 multiply with this factor F32. For example, take the 0 minus with 0 multiply with the factor F32, you still obtain 0 here. Take the negative 0.19 minus with 7.00333 and multiply with the factor F32 here, then you should obtain 0 as well. Lastly, 10.02 minus with negative 0.293333 multiply with the factor F32, then you should be able to obtain this answer. So you can see that your upper triangular matrix, U matrix here, is the second forward elimination result. Then we success to obtain the L matrix and U matrix, where for the L matrix, you have always 1 in the diagonal. So since this is the lower triangular matrix, so you have 0 at top and non-zero at the lower part. For the upper triangular matrix, you have non-zero at the upper part, and the rest you have 0. As you can see, we can obtain the L and U matrix by using the forward elimination according to the Gauss elimination method. As long as your system matrix A is unchanged and remain constant, then we just need to perform the forward elimination once to obtain the LU decomposition. If the A matrix here is remain constant, then your L and U matrix will be unchanged as well. You can check the accuracy for the lower and upper matrix here by using this formula. Take the lower matrix, multiply with your upper matrix, and the result LU should be equal to the A matrix. If LU matrices are accurate, then we can proceed for the second step, which is the forward substitution. So this is the formula that we use, and then we can substitute the B, which is the output matrix here. So B is equal to this, we substitute inside, and your lower matrix is obtained from here, we can substitute inside, and you are going to find the D matrix. By multiply the first row with the column here, then you obtain the answer equal to 7.85. So on the left hand side, you obtain D1 equal to 7.85. Directly you obtain the answer for D1. And then you continue for the second row, multiply with this column, it should be equal to negative 19.3. So if you arrange the formula, on the left hand side you have the D2, on the right hand side you have negative 19.3 minus with 0.1 divided by 3 multiplied with D1. So you can substitute your D1 inside, and then you should be able to obtain the answer for D2. Lastly, take the third row, multiply with this column, and you should get 71.4. Then rearrange the formula where you have the D3 in the left hand side and the rest you put at the right hand side. So you can substitute your D1 and D2 from these two formula, and then you can get the answer for D3. Then we can continue with the backward substitution by using the equation Ux equal to D, and D is obtained from here. So previously, once you do the calculation, you should obtain this result for the D1, D2 and D3. Backward substitution means that you start the substitution from the last row. So take the last row, multiply with this column, you obtain the answer to be 70.08 something. So you can obtain your x3 here. So your x3 equal to 70.08 divided by 10.01. And you can continue for the second row, multiply with this column, equal to negative 19.5617. So you should know 0 multiply x1, you obtain 0. 7.033 multiply x2 plus negative 29 something multiply with x3 equal to negative 19.56. So if you arrange the x2 on your left hand side, you should obtain this result on the right hand side. And then substitute the x3 result here into this formula, then you should obtain your x2 to be negative 2.5. Lastly, take the first row, multiply with this column, equal to 7.85. Then you can do multiplication in between them and rearrange the formula x1 on the left hand side and the remaining term put on the right hand side. So you can see that you need x3 and x2 result and substitute inside this formula, and once you do that, you should be able to obtain your x1 equal to 3. You can check the accuracy of this answer by substitute the x1, x2, x3 inside this formula and check the left hand side. If you multiply between these two, it should be equal to your right hand side. So if the answer is close to the right hand side, then we say the answer is accurate. In this example 2, we have the same matrix A, which is the system matrix, as the example 1. And we have a new right hand side matrix, which is B2. We assume that 2 here means the data is correct at T2. Since A matrix is remain the same, therefore L and U matrix are also the same. Then we can directly get the answer for LU without computing the forward elimination. We just need to perform the forward and backward substitution in the step 2 and 3. So our L and U matrix is remain the same, and your B matrix is changed to this 30, 20 and 10. You substitute inside and you can compute your D1, D2 and D3. So once you compute D1, D2, D3, you should obtain this answer, and then you perform the backward substitution to find your x1, x2 and x3. You see, this method is efficient compared to the Gaussian elimination because we do not need to repeat step 1 many times as long as the A matrix is remain the same. We can easily use the substitution to find the answer. In the first example and second example, you see the matrix A, which is the system matrix, remain the same, and your right hand side function change from time to time. So let's say at time 1, you have your input 1, and this is your output at time 1. And at time 2, you have your input x2, and then this is your output at t2. We can also combine various sets of input and output in one equation. So for example, since the system matrix is remain the same, you only have one matrix A here, and your matrix X is combined by the first input and second input, which is written in these two columns, and your output 1 and output 2 is written over here. You must know how to read these. So let's say you have a system, and your system is given by matrix A. Let's say you have the input, and you have multiple input, like this case, you have 2 inputs. So you should know when you give the input x at time equal to 1, which is this column, then you should obtain your output B at time equal to 1, which is this column. So if you give the second input, which is x2, to the system, then you have the output B2. And if you have additional input and output, you should continue put the additional column. If you have multiple input and multiple output, like this case, we do not need to perform our calculation separately. Since the matrix A is the same, then you have the same L and U matrix. So we can proceed for the step 2, which is the LD equal to B. And this is your L that can be obtained from the forward elimination in the step 1, where you already obtained this previously. Since you have 2 output in this case, therefore we have 2 columns for your B matrix. And you also have 2 columns in your D matrix. First column is corresponding to the first output, and then second column is corresponding to the second output. We can solve the D matrix here by repeating the same procedure in example 1 and 2. For example, we take the first row, multiply with the column here, then you should obtain the answer equal to 7.85. So you multiply the element inside, you obtain D1, the 0 multiply D2 here, you obtain 0, 0 multiply D3 here, you obtain 0, equal to 7.85. With that, you can continue for the second row with this column to obtain this answer. Then you can continue to find your D2, and then take the third row, multiply with this column equal to 71.4, then you can find the D3. So D1, D2, D3 at the first column here can be found by using this. You can continue with the first row, multiply with the second column. Let's say if you multiply, you have D1, 2, multiply with the 1, you get this, plus 0 plus 0 equal to 30. Therefore, your D12 is 30. And you continue with the second row, multiply with this column equal to 20, you can find the answer for D22. Lastly, take the third row, multiply with this column, and then you should be able to obtain 10. Then solve the D32. So with that, you obtain the answer for D12, D22, and D32 here. With that, you should know that if we take the row here, multiply with the column here, it should be equal to 7.85. And then you should obtain your answer for D11, which is 7.85. By repeating the same procedure for the other row and column here, and you should obtain this answer for your D matrix. Then we can continue for the step 3, which is the backward substitution. So we have the formula Ux equal to D, where this is your U matrix and this is your D matrix that has been found in the step 2. So now we are going to find the X matrix. Backward substitution, we start from the last row, multiply with the first column, you get the answer 70.0843. So if you multiply this element corresponding, so you should get 0 plus 0 plus 10.012 multiplied with x31 equal to 70. Then you can find your x31 answer. So you continue, take the second row, multiply with this column, give you this answer. Then multiply this element corresponding. So 0 multiply this, 7 multiply this, and negative 0.29 multiply this equal to negative 19 point something here. Then you can find the answer for the x21. We can continue for this row, multiply with this column, give you this answer. So you multiply the element, 3 multiply x11 plus negative 0.1 multiply x21 plus negative 0.2 multiply x31 equal to 7.85. And from this equation, you should be able to obtain x11. And you can repeat the procedure here. Take this row, multiply with this column equal to this, and you can find the x32. Take the second row here, multiply the second column, then equal to 19. Then you should be able to obtain x22. Lastly, take the first row, multiply with the second column equal to 30. Then you can find the x12. So we are just repeating the previous step in example 1 and 2 to find your X matrix. So you should see the steps are similar. In general, for the backward substitution, we start from the last row, multiply with the column here, give you this answer. And from this equation, we can find the x31, which is equal to this answer. And if you continue for the second row, multiply with this column, you obtain this answer. Continue with the first row, multiply this column, you get this answer. And if you repeat for the same procedure for the second column here, then you should obtain the result for x123 at second column here, which is this. With that, we success to find the X matrix, which is the multiple input from the multiple output here. So this is the answer. To check the accuracy, we can substitute into the left hand side function here and compute the multiplication for these two terms. So once you get the answer, you compare to the right hand side. If they are equal, then we say this solution is accurate.